So this question was testing on curve sketching. So we have to find the main, horizontal and vertical asymptotes, and then sketch the graph. So in this case, so we'll have the function is f of x given by 1 over x squared minus 1. So the main of the function is simply obtained by excluding all those possibilities, values of x that will give a 0 as a denominator, because this is a rational function. So remember, this can as well be written as 1 over x minus 1, x plus 1. These are difference of two squares. So the main of f will be the solution to this such that we don't get a 0 value. So this means x minus 1 should not be 0, or x plus 1 should not be 0. So which means x should not be 1, or x should not be negative 1. So therefore, we say the main of the function f is this set from minus infinity to negative 1, then from negative 1 to 1, then from 1 positive infinity. So it's splitting the interval into three interval from negative infinity to positive infinity into three subintervals. So say this is 0, negative 1, 1. This is infinity, this negative infinity. So we have to discuss this graph in this interval, say A, B, then C. So let's get the derivatives of the function, first and second derivative. So the first derivative of the function is given by negative 2x over x squared minus 1 squared. You can always use differentiation by quotient rule to be able to find that solution. And if you differentiate this one, second derivative of the function is 6x squared plus 2 divided by x squared minus 1 power 3. Now, for x, less than 0. So remember, we also have zero is also one of the points of reference. So actually, we can say before we start now describing this, so let's get the asymptotes. Now, vertical asymptote. Now, remember vertical asymptotes, we actually solve the equation denominator equals to 0. So we had x plus 1, x minus 1 equals to 0. So which means we have x equals to negative 1 and x equals to positive 1 are the vertical asymptotes. And then horizontal asymptotes with horizontal asymptote we need to define this limit as x approaches plus or minus infinity of f of x. And you see, when you say limit as x approaches now positive infinity of 1 over x squared plus 1 minus 1, we get this one to be 0. And also, if we get limit as x approaches minus infinity of 1 over x squared minus 1 is also 0. So therefore, the horizontal asymptote is y equals to 0. This is simply the x-axis. So now what, because now we were asked to find the domain, we have already defined the domain, and then we also have the asymptotes. So let's sketch and then use the asymptotes to know the orientation of the graph. So if this is our y-axis, so this -1, this +1, this x-axis. So the vertical axis are the lines x equals to -1 and x equals to 1. So let's show them on the graph. And then x equals to 1. And then, of course, the x-axis is the horizontal axis. Now we have to know how the function is behaving as we move towards this x equals to 1 asymptote. Now limit as x approaches 1. Now this line from the right, so this direction of 1 over x squared minus 1. Now if you put, say, a value 2, so we'll have a half. If you put here 2 squared, then we'll have 2 squared, which is 4. 4 minus 1 is 3. And assuming I put here, say, 10, which is a value to the right, then I'll have 1 over 10 squared is 100 minus 1, which will be given by 1 over 99. And then if you put here, say, for x to be, say, 1.11, then I'll have 1.11 squared minus 1, and then 1 divided by that answer, I get 4. Limit, when I put 1.1, then this limit will be 4.3084. So that tells us that as we move closer to this asymptote x equals to 1, then the value of the function f of x is becoming larger. So this is how the graph will behave. So this is how the graph is behaving. So growing larger means that then you are moving towards higher values of y. And then as the function approaches this asymptote x, the line x equals to y equals to 0. So this being an asymptote, this line and this one, and we are saying that this is how the graph is, the branch of the graph is behaving, then it tells us that in this interval, then the graph is showing this orientation. This is how the graph behaves in that interval. And then as let's see what happens in this interval here. As x approaches -1 from the +1 from the left. So let's see what happens between this region here. So our say value 0.9. So 1 over 0.9 squared minus 1. So it'll be 0.9 squared minus 1 will be negative 0.19. And then if you say, even when you put 0 here, so we'll have 0 squared minus 1, you get -1. So it tells us that in this, when you approach this asymptote x equals to 1 from the left, then you are going to get a value in this direction towards -infinity. So the values are becoming negative, and the value of the negative values increase in that manner. So this is how the orientation of the graph will be in this interval around this asymptote x equals to 1. Now for -1, as we move towards -1 from the left, then we'll have x, say, if I pick x to be -0.9, so I'll have 1 over -0.9 squared, and then minus 1. Actually, we get the same interpretation for this other asymptote. So the value will still be negative. And then around this line, x equals to the line y equals to 0, which is another asymptote, then having this interval from -1 to +1, and this is how the graph behaves. So this moving towards -infinity is also moving towards -infinity. Then the graph in this interval between the asymptote, the horizontal asymptote and the vertical asymptote, will be this is how the graph will be looking like. And then, so because we have already done with this interval, and then the remaining part is this other interval here, from -infinity to -1. So this being a horizontal asymptote, so either we can either get an arm of the graph in this part or this other part. Now, how does the function behave as we move closer to -1 from the left? So assuming I pick a value, say -2, I'll have 1 over -2 squared minus 1. So this will give me 1 over 4 minus 3, which is a positive value. But then when I say I pick, say, 1.5. So I'll have negative 1.5 squared minus 1, and then 1 divided by the answer, I get 0.8. Now, the first value was 1 divided by 3, which is roughly 0.3. And then if I pick, say, negative 1.02, I'll have negative 1.02 squared, then the reciprocal of the answer. So negative 1.02 squared, then minus 1. And then reciprocal of that, I'll get 24.7524 etc. So the thing is that as we move closer to this asymptote from the left, then the values of the function are growing larger. And because this is also another asymptote, so then it tells us that this is how, or this is the orientation of the graph. And so we can finally locate or finally sketch the arm in this interval negative infinity to positive infinity. And the arm will be so this is how we can sketch that given graph. So remember, we have done this analysis because the question was specifically specifying to identify the domain, horizontal asymptote and vertical asymptotes, and then use that information to sketch the graph. So that's how we use the concept of asymptotes and domain of the function to draw the graph. Remember also, we can also use the first and second derivatives to draw the graphs or sketch the graphs of functions. But then in this respect, we're just being asked to identify the asymptotes and then with the domain of the function, use the asymptotes to actually do the sketch of the defined function. So that is what we are supposed to do in this problem. Thank you.